too wide of an angle. Okay.
But then isn't it gonna get your back?
Yeah, it would, but
You need a helmet cam.
what can we do? All right.
Because that's where you got it last time.
Oh yeah, and it was just my bag, wasn't it? Oh well, we'll do it here. I'll just stay in this one spot. All right. That's going to be an interesting part of the video. All right. So chapter 2 is all about solving equations. And some of us started solving equations before we had equations, so we want to kind of get there. This should be something that you've just done quite a bit of, but let me see where everybody kind of is with solving some basic equations. It might have been a long time since you've done this, so that's why I want to kind of go a little bit slower. Yeah. So section 2.1. They really break it down in these first few sections of chapter 2. Is it all right?
I think you need to go up like a little higher. There we go. Yeah, it's
All right.
perfect.
If I do them any higher, it's going to...
It's got the whole board
That's that. All right.
back there.
Section 2.1 deals with just adding, subtracting. So what I mean by that is if I had an equation like this, x plus 4 equals 7. Subtract 4, exactly. So, and this is really, the real basics are stuff that we can do in our head. If I said, what number when you add it to 4 you get 7, you don't think you're doing algebra, but in a way you are, because you're saying, I don't know that first one. If I take 4 away, I can figure out what the first one is. So that's why the x just takes place of that first one. Right? It's a placeholder. So sure enough, you minus 4, x equals 3. And how do you check that for any equation? Plug it back in. All right. So a little, just want to make sure we're all on the decent page. And that's really what section 2.1 focuses on. It doesn't get too deeper than that. It'll do something like, it might even throw fractions at you, but you should not be scared. So how do you solve that one for x? What do you do?
Add 11
Exactly.
ninths to
And you see how the idea is always you do the opposite operation than what's being done now. It only makes sense. I'm trying to strip away crap to get at what x is. So like if somebody dumped dirt on top of something and I want to find out what the hell it is, I'm going to have to undump it. I'm going to have to get the hell out of the way. So I always think about, I'm trying to get that stupid thing out of the way so I see what x is. So you add 11 ninths to cancel it. So on this side I am just left with x. And what's negative 4 ninths plus 11 ninths?
8 ninths.
Careful.
Oh, 7 ninths.
Oh, 7 ninths. Okay. And again, 7 ninths minus 11 ninths, sure enough, would be negative 4 ninths, so it works.
What if it's not the same?
Good. If it's not the same denominator, it's just now it's not really a chapter 2 problem, it's a chapter 1 problem. Because then you just have to remember to get like denominators, right? So if I had, what do you have, Jeff? I don't know. If I have
1/3.
4/5 plus x equals, you can do it, Jeff. 3 15ths. 3. Let's make 2 15ths because you can reduce it. Okay.
So then you take away 4/5.
Exactly. So this is the first step in this, really this whole section. They're going to try to focus on not having to divide yet. They want to focus on just adding, subtracting. So you're always going to have to end up with just an x, right? So sure enough, if I subtract the 4/5 away, what's the LCD going to be here? So this one you can leave alone. This one you got to multiply by 3. What's 2 15ths minus 12 15ths? I know. Is that the answer? Not quite. It's the right number, but it's not in the right format because you always have to reduce if you can. Right? Didn't have to reduce that one because it wasn't reducible. That one, though, reduces to what?
5.
Yeah, good, because 5 goes into both.
Yeah.
So 2/3. I love it. Cool. Okay. It's not too bad. I mean, you just got to remember, if I'm adding subtracting fractions, I must have an LCD. You must. And the whole idea of LCD is just building up both, or maybe just one, so that they agree. And then you can put them together. Okay? And it really is, I think I said this before, but it really is like terms. Here I got 4/5. Here I've got 2/15, not like terms. But now I made it so I have 2/15 and negative 12/15. So how many 15ths do I have? See, now I've made it like terms. Which is like 2x and negative 12x. Whereas this was 2x and negative 4y. It was something else. You can kind of see that like denominators really is the same idea as like terms. Exactly the same idea. Okay. So what's the next level? Because I'm hoping that I can assume that everybody's cool with that kind of thing. Right? The only way they can make some of these equations really difficult is to throw decimals or fractions in there. Right? What about multiplying and dividing? How would you do this one here? And have I told you about this here? I'm going to do like a Roman numeral stuff.
Yeah.
All right, just do it without even thinking about it. But I was at some point in this semester, what is that thing? All right, the Roman numeral. I just do it. I don't even think about it. What if you had watch it? X over 3 equals 4.
Multiply it by 3.
Yeah, exactly. And again, what's the idea? You undo what's being done
Yeah.
to dig the x out, right? It's being divided by 3, so how would I kill the 3? Multiply by 3.
12.
12. I love it. Good. All right. So what if I had this here? Well, this would not be too evil. Let me do this one to you. Yeah, okay. Well,
6 times.
divide by 6. X is 2. But here's the funky thing. I'll give somebody this question, and I'll get the same answer. I shouldn't get the same answer. That's a different equation. Totally different equation. If you get 2 for that equation, you're not doing enough work. You're guessing ahead of time.
It's 1/2.
You see the 6 and the 12 goes in twice. The answer's 2. No. What do you divide by? 12. You're trying to get the x by itself. You divide by the 12, you won't make the mistake. What should it be? Not 2. It should be
1/2.
1/2. Cool. So don't just see an 8 and a 4 and say 2, yay. You do it so you don't make that mistake. You actually divide by the 8 or whatever, so you don't go the wrong way. Okay, so far, hopefully that looks like most of you guys are like, yeah, Jeff, I know this. Good. You should know this stuff. Now here's the part that we might need to focus on. We do it just a little bit more, and I'm going to give you guys some problems to work on together. What gets more interesting is when they have either several things at once, or let me give you one before I get too far away from this stuff. Who knows the shortcut to doing this kind of problem? Exactly. Because if you think about it one thing at a time, how would I kill the 5? What would I have to do to both sides to cancel the 5 out? Multiply. Because right now it's being divided, so I have to do the opposite operation, multiply. What would I do to the 4 to kill it? Divide. So why don't I do just both at once? And some of you guys probably remember this, multiply by the reciprocal, right? If I multiply by 5 over 4, you can put that over 1 if you want to. Obviously those,
Cancel.
now what's left here?
X.
Yeah, just the 1x, right? 1 from that, so just an x. Equals, I love it, because 4 goes into 24. 6 times 5.
It's 30.
30. Sweet. So remember that multiply by the reciprocal when you have that fractional coefficient. You can kill it all at once. Right? So, number 8. Here we go. I want you guys to try this one out by yourselves. See what happens. It's kind of like the next level. So if you guys remember what to do here.
We're gonna add first
Oh,
time
wait.
3.
Right out. I'm sorry. That's right. What's he doing? Doesn't have too much juice left.
That's the seven.
Negative 7.
I think ahead to how to handle this on my phone.
So you put that in the negative. Always carry your signs. So that way you don't forget.
So there's a couple main ways to go at this. All that really matters, and who remembers the phrase that gets you through this? What do you want to do with the x's? What do you want to do with your numbers?
Keep them together.
Get 'em
Yeah,
one
get
side.
your x's on one side, your numbers on the other side, right? That's the whole idea. So you pick a direction to go. So some people don't like negative numbers, so they always move it the way that's going to make it end up positive. Some people like their x's always on this side, so they're going to move it so that they're on that side. So which way did somebody do it?
I did,
Plus 3. I subtracted 4.
Subtracted the 4x and then but you did the other way then.
I
Okay.
subtracted.
So if you subtract the 4x on this side, of course you get the,
3.
and on that side you get
2x
2x.
plus 11.
plus 11.
And then you subtract the 11.
Beautiful. So you picked your letters to go this way. Your numbers better go the other way. So the minus 11 cancels.
Negative 14. Then divide by
X
2.
equal
Divide by 2. You almost always divide last. If you divide too early, you make fractions where you don't really need fractions, right? Because I ended up with a nice even number that 2 goes into. The other way to do this, and of course you get the same answer, is to subtract 6x this way, right?
Yep.
So now you get your x's together on this side. You get negative 2x minus 3 equals 11. For some reason, I get people that numbers move just by themselves. They somehow, that negative 3 somehow just goes over there. You really want to make sure that you bring everything down exactly where it is right now. They just can't migrate to the other side. To get to the other side, they have to like change sign, right?
Mm-hmm.
So be careful. I always get people that don't realize how important it is that equals stay where it is. Everybody stays where they are until you move them yourself. What do I want to move down?
With negative 3, you want to add it.
Yeah, I'm going to add 3 so it cancels there. So we get negative 2x equals 14.
Divide by 2.
Divide by negative 2. X equals, same thing, thank God. Right? So no matter which way you solve it, it better come out to the same answer. Cool, yeah.
But you can't start with numbers, you have to do the one variable.
Oh, no, I could have added 3 first. Yeah, you're right. And that's another way, I don't want to give a billion different ways to do one problem. But you could have done the adding of the 3 first and the subtracting the 6x second. You would have ended up at the same place. Cool. As long as the x's go one way and the numbers go the other way, you're good. Okay. So did that feel decently okay? I mean, did you guys do all right?
Yeah.
Oh, yeah.
Maybe you left a negative out or something, nothing too major. As long as you know the concept, that's what I grade on more of. What about this one? Here's the next level up. Let me start over my, let me say next level. So example 1 at the next level. I want to get into my IX and XII and all that kind of stuff. And this kind of goes to that problem we had earlier that wasn't an equation yet. Oh, let me not do that. Yeah, sure. Work that out. Let's see if we remember what we did first last time when we had a problem like this.
That's all you keep.
That'd be good. Yeah. I already dropped it enough. Okay. Duh, Jeff. That works.
Five equals. I did it, baby.
You got it.
That's gonna be on I get so happy when I get the right answer.
No, trust
I
me.
feel so
It doesn't
confident.
matter what level of math you're in, trust me. When one problem takes like 8 pages, just imagine how happy you are. It sucks when you get to the bottom of 8 pages
And then you're just
and it's wrong, you're like,
that.
Oh.
shit. Alright, so what's the very first step here?
Multiply with 3.
Beautiful. You always want to distribute where you can so you free them all up so they can move.
Mm-hmm.
It's all about moving stuff to one side or the other. So here I get
12 minus 3y plus 5y equals 6y plus 4.
So, trust me on this. I know a few of you guys have trouble with this. It is all about organization. Everything's exactly the same place as it was. I just rewrote what this is. This is this. Everything stayed in the same place. Right? There seems to be a little bit of an issue of symbols moving around, then you make a new equation. It's not the same equation they ask you about. Next thing I want to do.
Subtract the 12.
Good. Like terms.
12 plus 2y.
I love it. Bigger one is positive, so it ends up positive. And now you almost always end up in a spot where you got to just pick a way to go. You want to make it go this way, or you want to make it go that way. So we could do, I'm just going to do it one way this time. We could do minus 2y. You could have done minus 6y, or you could have done minus 12, or you could have done minus 4. They all end up at the same place. Right?
Mm-hmm.
Bam. So here I got 12,
Equals
nothing, equals
4y.
4y plus 4.
Take away 4.
Oh yeah, the negative 3y's plus 5y's. Beautiful. So just putting like terms together, right? That's what I call cleanup. You clean up both sides before you start moving stuff around, right? Now, since I moved my eyes that way, I want to move my numbers
the other way.
the other way. So I get 8 equals 4y.
Divided by 4.
And this is one where you actually do get a nice whole number, right? And to check it, you just throw it back in. 3 times 4 minus 2 is 3 times 2 is 6. Plus 5 times 2 is 10. 16 is 12 plus 4, 6 times 2 is 4 is 16. So it works. If you plug that back in, it works.
You want to have the same on both sides.
Exactly. That's what this is claiming. So here's what we really say when we write this. We're saying that this is true when this is true. So to check it, we throw this in and see if it does come out true. If I end up with 16 equals 2, something went wrong somewhere. What really sucks is when you get the right answer and you just worked it out wrong when you plugged it in. That sucks. You're like second guessing yourself. Yeah.
I have a question about like showing work. When you say like you show us where to show work and stuff like that. So how I work it out is like I cancel it out automatically in my head. And that seems like do I actually have to show you it on my paper? Because my handwriting sucks really bad.
This is one reason why I want some of this homework turned in kind of soon as you can get it done, so I can kind of find out specifics that are good or not good enough. If you show me some work, that's good. If you show me barely any work, that's bad. For two reasons. One, I'm not sure you're getting the answer correctly. Maybe it's coming from somewhere else. Or two, if you get the wrong answer, I have no idea why. And that's no good. I need to know why you got the wrong answer so I can help you out. If I don't know why you got it, I have no way to help you out. Okay, cool. So err on the side of more work. But, I mean, try and do it your way first, and I'll tell you if it's good enough or not. Or you can come show me some examples. Okay. Oh. That will work. Stay. Okay. Oh, I'm way back there. All right. Let's try one more out. Let me see here. Or at least one more out. Yeah, let's do this one. No, let's do one like that. Let's see. So we'll do a problem like that, and then we'll try one out with some fractions in it. We'll see how we're feeling at that point. Oh, cool.
I had a question in class. Before you do that, can you do this outside of it? So you can.
So that's one reason why I made this problem. This is subtraction, but what operation is here?
Oh wait, you just do the 2, not the 6.
You've got to do subtraction last, right? So you don't make this a 4.
Yeah. So you do 2 and then distribute and then put.
Oh, cool.
How do you do that?
Hmm?
Exactly, you do it.
See?
This guy, 6 minus 2,
With the 10
which is 4.
Then it said,
so it's okay to
because
do
you
six
can't do
minus
that because you do PEMDAS. You have to do it.
And the 8
But
is,
you can't. So
is it positive or negative?
Okay. So now, you
So
combine
that's
like
the thing to be
terms.
careful when we start moving stuff
6
around.
minus
The sign in front's going to
negative
stay
10.
with that thing.
That's the
you know?
same thing as that. So 6 minus negative would be positive 14. Just take it out. Just don't look at that 8x. So the 6
Yeah.
minus the negative.
And the-
And we're going to be a positive 14. But, okay, okay. 60, I mean, sorry.
So it'd be negative 16 take away.
It would be negative 8x plus 14.
It's not negative.
No, just don't look at that. So you have a 6 minus a negative number. So if you just want to, don't look at that 8. If you want to write it, 6 minus negative 10.
All right, guys. So what's your first step here?
Distribute.
What'd you say? So take the negative 2 through. Yeah. So order operations always saves you, right? Order operations saves you. I can't subtract before I multiply. Right? MD is before AS in PEMDAS, so I've got to do the multiplication division level first. So that means distributing this. Now, when you distribute this, my suggestion is don't just distribute the 2, it's a negative 2.
Mm-hmm.
So negative 2 times 4x,
Negative 8.
negative 8x, negative 2 times 5,
Negative 30.
negative 10, careful now, not 6.
Oh,
Just the 2, yeah.
Negative 15.
So everybody see that?
Yeah.
Because
Wait, I
negative
have a
2 times that is this. Just put a 6 out front, right? Okay. Over there, what do you get?
Oh, that's what I did.
negative 15
Gosh, I'm such a
plus
freak.
3x.
Cool. Right. So you guys notice how I'm writing everything? This is still here. This is still here. Don't let things get out of order. And now on each side, I can clean it up a little bit. What are your like terms over here? Good. 6 minus 10. Negative 4. And 3x and x.
I screwed that one way up.
Do you see where I went wrong? What happened?
Yeah, I know exactly what I did wrong.
What happened?
I went stupid.
Oh, okay. What do you mean you went stupid?
Well, no, I just did it way too fast and wasn't thinking. Yeah, no,
all right.
I'm embarrassed.
I won't grill you anymore. I
Thank
like
you.
that explanation. What happened? I went stupid. So now I've gotten to that level I was talking about before. You just choose which way to go now, right? You simplified both sides as much as you can. Now you start moving it around. So, what do you do? Minus 4x? Okay. Some of you guys probably added 8x. You'll see how I get the same answer eventually. On this side, it cancels. Here you get negative 4 minus 12x. Negative 15 and this cancel. So now you
Yeah.
want to, beautiful, you move the x's this way, you want to move the numbers that way. So you want to do something over here so they cancel. Same thing to both sides. Now what I always see is this. What mistake did somebody make right there? Yeah, 12 is negative. Don't leave the negative out, right? On any level, like right here, this is a negative 8x. It can't become positive, so don't forget those negatives in front. The signs in front of something have to stay with that thing. And then the last step.
By yeah, positive. Or,
Now, I know it's a fraction, but why are we not so concerned? Because we're done. If you wanted to check it, you're not done. And that gets ugly. Right? But I'm basically done. I don't care.
I lost my mind on that one.
I'm confused.
I have a question.
Yes.
How did you
No, you're here. Oh, just divide.
Here,
Yeah, where did
6 minus 10.
Oh, it's 10.
Yeah. And you can read it off exactly how it's written. If it's all on one side, you don't have to move anything. 6 minus 10, negative 4, minus 8x is still there.
Did you put the negative 4 on the other side to make it
No, because there's only one negative 4.
Because, like, when I was at the
So I could put the answer here or there.
That's what I'm saying.
If you put another negative 4 there,
Yeah.
oh, not another one.
I went stupid and yeah, I know.
Oh, yeah.
Totally wrong.
Why is the final answer not negative? How do they cancel each other out?
Oh, a negative divided by negative.
But it stays the same fraction though? You
Oh,
don't-
yeah. Because there's an understood negative 1 out here, really, right? Negative 1 divided by negative 1 is positive 1. So those negatives cancel. Yeah. Cool.
Usually as long as you remember PEMDAS and like do it in chunks, you should be fine.
Yeah, exactly. And actually, the way you said that, doing it in chunks. The people who do really well at math kind of naturally only worry about one piece of it at a time. I seem to hear from people as I tutor them or talk to them that everything is in their head at once and they're concerned about everything. I'm like, why do I care about that side when I'm just distributing that? All I care about is what's negative 2 times 4 right now. And that's easy. But our brains are trying to go ahead of us and we start messing up here and that's going to mess us up everywhere. Only worry about what you're immediately doing. Right? And you'll be a lot better, trust me. If you try to rush to the answer, you've not saved any time because you've got a wrong freaking answer. It's not good. Any other questions about this? So yeah. Oh yeah, sure. Yeah. You guys can come and go. It's a college class, so it's totally up to you. So yeah, if you have an appointment or something, you can let me know, or just sit near the door. It's cool. Don't worry about it. I won't take it personal. Any other big questions about this problem? So notice how we first distribute, then like terms on both sides, then decide which way to move stuff, right? That really gets us through almost all the simple equations.
Can we just slide that over? So I can see Hey,
Sure. I think you should be, yeah.
yeah, you can erase it.
Someone puts it down.
Hmm?
If it
Oh yeah,
puts
there's a
it
seat here
down.
too if you want to.
Okay.
Yeah. Let me see. Okay, cool.
I'm not missing
Oh, so here's the last level we're going to talk about now. And that would be, what do you do when you have either fractions or decimals in an equation?
Round.
I always want the exact answer, so.
Oh.
You know us math teachers.
Yeah.
Let me see. So, for example, if I had 1/3 there you go. Nice and disgusting. Now, before I get into this, let me ask you something that will help me explain a question that I think will pop up from doing this problem. What is, and you don't write this down, just what is 2 times 3 times 4? 24. It's not 6 times 8. If I did write 6 times 8, do you understand what mistake I made? What mistake did I make?
Oh, you multiplied.
I multiplied 2 twice. How many 2's do I have up there?
1.
1. So of course, the minute I multiply 2 by 3, there's not another 2 to go for that guy. So that shouldn't be an 8. That should be 6 times 4 if I want to do it one step at a time, right? Which is, like you said, 24. Now what the hell has it got to do with this? We'll see. What part of that equation do I not like?
The whole thing.
If you had to pick one part of it. The fractions. So the really nice thing with equations, you cannot do this as if it's not an equation. If it's an equation, I'm allowed to do something to both sides, and it stays the same, right?
Mm-hmm.
What can I do to both sides to kill that fraction? I can kill both fractions, actually.
Multiplied by 3.
Not by the reciprocal, because if I do it by the reciprocal, then something might end up on the bottom again, right? So if that was the only fraction in there, what would I would multiply by 3. Would that kill this guy, though?
No. Yeah.
So what do I multiply to kill them both? 9. You multiply by the LCD. If I multiply this side by 9, what happens to those 9's?
Cancel.
Now, does anybody see why I don't have to multiply these by 9 also? That's why I did that. Right? They don't both get it. How many 9's did I multiply by? 1. What happened to it? It immediately died. So does this guy get a 9 distributed? No. The 9 died that I multiplied by. Yeah.
What if it's I know this is probably way ahead of myself, but what if it's like they don't have any common, like the denominator?
They'll have to. They have to, because either the reason that one was 9 is because 9 has a 3 in it. That's why it wasn't 27, right? But the minute you give me any numbers, 1 over 111 plus 2 over 307, the LCD is going to be 111 times 307. Because they don't have, you get right?
Yeah.
You're always guaranteed to have an LCD. Will they always be nice? No, hell no. If they have something in common, it'll be nicer. Because you don't have to double count that then. It's not 27 because he doesn't need a 3. He's already got a 3. That's why it's a nicer number. That's why it's only 9. Do you guys see that? LCD, lowest common denominator. You only multiply them when they don't share anything. There's nothing to not overlap then. They both need each other. Aw. A good common theme today. Aw. So if I multiply that side by 9, it dies right there. What happens when I multiply this side by 9? I got to do the same thing to both sides.
Mm-hmm. You get 3.
3 goes into 9 3 times.
Mm-hmm.
So let's rewrite what I got here. I got 3 times this equals 2 times this. Let me just step back from that and see if you guys agree with me. I like that anyway. Whatever. I really want you to see. Let me see. Maybe if I do this backwards. Let me try this out.
I get it. That makes sense.
See, I've never tried to explain it like this, but let's see if this makes sense. Don't write this down. Just watch. I can multiply or divide the sides by anything I want to, except for 0. Is that cool? If you can multiply by 0, you'd have no equations anywhere. It's kind of simple. Right? Smartphones would not exist because they need equations to figure them out. So, I could divide both sides by 9, couldn't I, if I really wanted to? It's kind of stupid to do that, but could I? Yeah, I could divide both sides by 18 billion if I wanted to. Would it help me solve it? No. But could I? Yes. If I divide both sides by 9, what happens here?
That comes 1/3.
1/3, right? So it'd be 1/3 x minus 5. What happens here? Do they cancel at all?
Nope.
So it's 2 ninths, 6 minus 5x. So I took something that was nice and I divided by 9 to make it ugly. So how do I save it again? How do I bring it back to being nice? I multiply by the freaking 9. I don't know if that helps out. That's why when it started here, it was ugly. Some evil person divided by something to make it ugly. So I just got to multiply by something to make it nice again, to make it whole numbers. So you multiply by the denominator or the LCD if there's more than one fraction,
Wait,
and
so
you're guaranteed to have a whole number left. Because 9 has a 3 in it. It's going to cancel the bottom totally. There's some left over, but I don't care. The bottom's gone. That's the only part that hurt me. I don't care that there's a 2 up there. I care that there's a 9 down there. That's what makes it kind of suck. Yes?
in this one you went back a step, basically?
Yes. But I wanted you to see. Does that make sense what happened here?
You went
Damn.
Yes.
I'm trying.
you went from that back to that.
Yes, just to show you how would I, this is where we started here, right? This one
Yeah.
is where this problem started.
Mm-hmm.
What did I do here to get to this ugliness? I divided by 9. So what do I do to make it back to where the nice part? I multiply by 9 to kill those bottoms. Yes, ma'am.
So if one's a fraction and that, like if the other one was a regular number,
You only have to multiply by the denominator of that one fraction. Yeah.
you
Well,
wouldn't have to do it to the other side, right?
I don't have to yell as much. It's awesome. But be careful. Whatever you do on one side, you've got to do the same thing to the
That's
other
what I
side.
was wondering. So if this side third and that side was just 2.
2, yeah.
Yeah, and then
You couldn't multiply one side and leave the other side alone,
okay.
right? For example, watch this. 5 is 2 plus 3, right? What's twice 5? No, twice 5. Twice.
Oh.
Put it way up there, but twice 5. 10. If I leave the other side alone, it obviously is not the same anymore, is it?
Yeah.
So I better double the other side. And what's twice 2?
6.
Twice 2?
Oh, 4.
4. Twice 3? So that makes it 6. I like that was a little painful, but we got there. Now that's a very basic thing, but sometimes teachers don't really focus on it enough in the early going, so it kind of escapes us what the hell's going on. That's why we have to do the same thing to both sides. Because if I have a true statement, 5 equals 2 plus 3, and I only change one side, it's not going to be true anymore. I was thinking about that. This is an old reference. Let me see. Have you guys all seen Indiana Jones
Yeah.
and the Raiders of the Lost Ark?
Yeah.
The first one? Not the last one, not whatever the hell that
The
was.
first one with Sean Connery.
Remember the scene where he had to put the bag of sand in place of the little
Yeah.
idol? And he messed it up because he didn't make it equal, right?
Yeah.
So if you put the same exact amount of weight, so whatever you do to something, you got to do the same thing to the other side. So if I've got to keep the balance. So if I double this side, I've got to double that side to keep the balance, right?
Yes.
So, all right. So does it matter then what's on the sides? No. If I multiply one side by 9, I've got to multiply the other side by 9. I don't care what's over there. I've got to, or else it's not true anymore. Okay. We'll do another one like this here in a minute. What can I do now? Now from here it should be relatively easy.
You like turn or
Right,
whatever you
distribute.
There you go.
3x minus
15 equals 6 minus 10x.
Love it. And now you pick which way to go, right? You can
And
add the 10 extra. Everybody's going to agree go this way this time.
Mm-hmm.
So 13x
minus 15 equals 12.
equals 12, and this is gone,
Yep.
right? So just keep everything in a nice straight line.
And the 15,
Add the 15.
13x is 27.
So that's gone. 27
Divide by 13.
divided by 13 all right. So x equals 27 over 13. Whew.
I did the same.
Say again?
I did the same, but I did it differently.
I love it. There's more than one way to do this. What'd you do different?
I just keep like,
Did you keep the fractions or did you?
yeah.
Okay, so you multiply 2/9 in. I love it. So fractions are, if you're cool with fractions, you do not have to kill them, obviously. So I was making an assumption that most of us probably don't want to work with the fractions if we don't have to. So I don't blame you for wanting to get rid of them. If you're cool with leave them in there, I love it. Leave them there.
Do we simplify it to 2 and 1/3?
Now be careful, nothing goes in both because 13 is prime.
But
If that was 26, then it would divide by 13 and be 2.
but 2 and 1.
Oh, make it a mixed number.
Yeah.
That's not really a simplification step. You can give me either answer.
Oh, okay.
So what would it be as a mixed number?
2 and 1/13.
Exactly, because there's one extra from 26. That would have made it go in evenly, so there's an extra 1.
Yeah.
That's why there's 1/13. I
So
love it.
it
Okay.
doesn't matter. It's the same thing though.
So can you work that problem out in fractions? So you see how that's done?
Sure. And I'll do it 2 different ways then.
I'm not gonna watch.
2 more different ways, by the way. Okay, so if you were to keep the fractions, what would you get here?
1/3 x.
Minus
Minus-
5 over 3
I like it.
equal to 12 over 9
12 over 9, and you could reduce or whatever, but we can reduce now, right?
minus
Minus-
10x over 9.
I like it. So it's still the same problem, you just have fractions that you work with. I like it. So we could add the 10/9 x over,
Yep.
and we'll need an LCD there, right?
9.
So, do you always leave the denominator the same?
How do you mean?
Like, I noticed you kept the 3s.
Oh, just because what's under these already?
1.
1. So when I multiply that in, 2 times 6 is 12, 9 times 1 is 9.
Oh,
That's the only reason. If there was something underneath already, if there's another fraction inside here, then I'd have to multiply the denominators out.
Oh.
And I did, it's just that there were 1s.
right.
Yeah, cool. So here, I think I heard somebody say, you have to multiply this by what to make it over 9?
3.
So you get 3/9 plus 10/9,
13.
13/9, x, right?
Yep.
The minus 5/3 is still there. Equals 12/9 is still there. And that's gone.
So you add 5/3. So
You add 5/3. This will reduce, but actually it would make it, what would happen? Can you-
4/3.
It would make it exactly the same as that, so that's
Yeah.
kind of cool. So this would be, if I add the 5/3 over, and this is actually 4/3, and this is 5/3. What do I get on that side then?
9. Wait. I lost myself.
Which is?
Handwriting. Yeah. Okay. Oh, which is 3.
Which is 3,
Yeah.
right? So 13x over 9 equals 3. And then how do you cancel the 13 over 9?
Multiply with 9.
Multiply by 9/13. And sure enough, you get 3 times 9 is 27 over
13.
same thing we got over there. Either way you want to do it. So if fractions don't bother you too much, this is fine. If you don't like the fractions, you can always get rid of them in an equation. The equation allows you to multiply by, because doing it to both sides balances back out.
How come you didn't write out 3 nights? You just show that you multiplied.
Oh, because I was just trying to save time. So 3/9, yeah. That's what that is.
Oh, okay.
And then 3 and 10 makes 13. Okay. Maybe. Let me show you one last way before, and it's going to clear up a little bit what happened here, I think. So we got this here?
Yeah.
Okay. So let me try to bring it back to original way it was. This might help a little bit out. Tiny bit. Can't I write 1/3 of this as that over 3?
Yeah.
And can't I
Wait.
write 2 this
Yeah.
9, 2 this over 9?
Yeah.
And then who knows another way to do this problem then? Cross multiply. Do you guys remember cross multiply?
Oh,
3.
jeez, yeah.
Or multiply by 9 to kill this, and in the process you end up killing the 3, which is what I did in the first place. It's just maybe a little bit easier to look at when you see this. There really is just one fraction. That's why when I multiply by 9, it's gone. It can't go anywhere else. Right? Over here when I multiply by 9, you get a 3 left, and then I can distribute that 3 through. Do you guys see that?
Mm-hmm.
Way easier.
Cool. So if fractions don't freak you out too much, you can just leave them in. If fractions freak you out somewhat or a lot, you can kill them in an equation, right? Which is nice to know. I don't like that part. Let me kill it. Okay. Cool. Maybe. So that's obviously one of the harder problems in this section, is when they have multiple fractions running around. Let me give you guys a few to try on your own. This is starting on page 106. And I'll put them up on the board for the booklets out there.
Wait.
Oh, sorry.
I just need the very bottom.
So page 106. If you have the book with you, it's that little green section. At the bottom there, it's a summary of 2, 1 through 2, 3.
You also turn it in like
9/3. What's that?
No,
That's actually 3 whole ones.
I won't make this official group work, but you guys can work together if you want to.
13x over 9.
Or you're working alone if you want to, it's fine. A little group of 1.
Yeah, 3 over 1.
So page 106, do these. Do number 2.
9/13 here. And then over
Let's see, number 8.
yeah, with this. The reciprocal 9/13. Now they cross.
Something to do right
so
now.
what you do on this side, you do on this side. That's right. 9/13.
Number. Which one, Joe? I don't know. Number.
Yeah. Over here, then that would be.
Yes, 18.
3 times 9 is 27. 1 times 3 is 13. 13.
Let's see. Ooh, yeah, there's another one. Number 27. I think that's good for now. Oh, this isn't too bad. Okay. Has anybody tried to go see the videos online yet? Did you access them anyway? Huh?
I haven't seen the new ones, but I saw like all the stuff from like Math 60, Math 110.
Oh yeah,
like
okay,
that.
okay.
Nothing from our class.
So I'm trying to get them uploaded. Sometimes I have technical issues with my computer deciding to quit in the middle of uploading, and then I got to start over again. So hopefully I have videos always up there at least at most 2 days later. That's what I'm trying to do. Yeah.
So what is it again? The 16?
It's on the website. Just click on the videos link.
So what's your YouTube?
Username Waller is me. Yeah. Question.
I already forgot how to do it.
Don't forget, if you have your printout, turn it in today. If you didn't do that survey yet, or you forgot to print it out, I'll let you turn it
We're gonna
in
talk about
Wednesday. Yeah, we're talking about a Wednesday. I want to make sure that most of you guys have done it.
So turn them in.
On the way out, you can turn them in. Yeah.
Plus 3 equals.
that say P plus 2?
13 plus 2. What?
Because I didn't know if that said PT, but then I realized it was plus.
Okay. Oh, they got these up here. There's the fractions workshop, and there's word problems workshops up here.
What do they actually do though in the workshop?
I used to be the coordinator of the Math Study Center, so I did a lot of workshops too, and I will do a few myself. But they have handouts, and they talk about the basics, and they leave like more advanced stuff toward the end. So sometimes these you'll have like some 103, 110 students come in, but they start off with 90 level stuff, and then they kind of at the end they go up a little bit. So if you don't want to see the freaky ass stuff, you just leave it, right? Yeah. So you can do one of two things. You can either leave all the fractions, so get those together, move those x's over, put those in there, and you get like denominators, right? Or you can multiply everything by something that will kill all the denominators. What's the LCD of all of those?
Huh? Number 8.
4. So it's always the bigger one because it's gonna be something that
Multiply
they
this
can
side
all
by -2.
multiply up to become. Not what they all have in common, but what can they all become.
Those two cancel out.
So multiply everything by 4. Multiply both sides by 4, it would distribute to here
Get
and
to
there.
this side, you have to do that side. Multiply that side by -2.
Then all your fractions disappear.
That's it.
Yeah, so
Yeah, just so that way
you
I
can check
can
this
just
up
get rid
twice,
of
4 is 8.
that guy on
Plus
the bottom
8.
there. So that multiplied on this side.
Sure. Yeah.
So yeah, so if that was a 5, if that was x over -5, I multiply it by -5.
The 3/2 x.
But what you do on this side, you have to do to
You
the
could.
other side.
Those are like terms. Not like denominators yet, but they're like terms. So you can't add 3/2 and 3/4, right? They are both x's, but they're fractional coefficients. You can't add the coefficients until they have like denominators. Is that what the question is? Cool.
It's 1/4 minus 2.
We make these denominators the same.
What's 8 over 4? 15. That's nice. Yeah.
Alright. This one here. What else did I do? Multiplied this
No,
by
no,
4.
there's an email that I said, if you made it into my class, to add those.
Yeah,
Yeah.
multiplied this side by 4.
That means
so
if you
that
made
way
it in, and there were some people that didn't, that were on the
gets rid of that.
So I just did that because I didn't have a lot of time, and I wanted to
This
email,
side,
I didn't
multiply
want
it
to
by
have to
4.
dig out.
Get rid of that 4, so that becomes a whole number.
Oh, I see. Yeah, I don't know. Yeah, I think you were asking.
Break it down. That to me is like the best way to do it. Is like break it down.
Sounds like it's good.
Then that will be 12.
Yes.
This 4, that we cancel out. This is actually 4 over 1. So when you multiply these, 4 4s they cancel out, and you have the 3, okay, which is fine. So really, you have the 3 over 1.
So it would be like that. X still be there.
Yeah, okay, so you did this has to now bring down x minus 4.
Where we at? Oh, well, we'll see them all here in a minute. Yeah.
That you still have to multiply this 4 with this.
Oh yeah. So that's gonna be like,
Yes. Chapter review and chapter test.
So get rid of 2.
Whoa, sorry.
So that's going to be 6.
I think there was a very first.
Hold on, watch.
And then the next one is chapter review.
3/2.
True, because I had to break it up. Because it can only, I only want to
4
go
over 1.
images and that's all.
this 4 will get rid of that 2. This turns into a 2. So now you have 3 for 1 x times 2, which equals 6 over 1 x. Which is 6x.
So both sides of the opposite side of the
I did not do that to both sides, now did I?
So one side's negative, the other
I did that to both sides.
the answer's going to be negative. I don't care if the negative on this side. So you're
I
worried
did it in
about
my head.
then A minus 2 is 6.
So it'll be
But you're also putting everything together with 2. And overall, those different signs together.
it'll be 6x plus 3.
Dude, am I too? Were you like somebody who's balanced? I had a lot of eight. Way out. Alright, that's the exciting part of the video.
Okay, wait, yeah, okay. Yeah, okay.
Thank you.
What did you get to? You had -2?
Alright, guys.
I did something. I need to start writing down all my steps.
Let's try these out. What do you do on number 2 first? Now here, the funny thing is, notice, guys, if I divide by 2, it actually works, but most of the time, if that was a 15, I would have a fraction that I don't really need. So you almost always divide last. So you want to subtract that 8, I like it. So you have 2m equals 8.
M equals 4.
Divide by 2 to kill that 2, m equals 4. Cool. And you can always check yourself. Twice 4 is 8, plus 8 is 16, check. Alright, so you can always check yourself, that's nice. Number 8. X over -2 equals 8. Beautiful, multiply by -2. I love it. Don't multiply by positive, don't think I gotta change the sign. No, you're dividing by something, multiply by that thing. So multiply by -2. By -2, and you get x equals -16. I love it. Check yourself. -16 divided by -2. The negatives cancel. 16 over 2 is 8. Check. Check. Cool. Check 1, 2. All right. 18. Let's see now. Well, what's your first step on this problem here? I'm going to kind of do that first step over here. Is that cool?
Yeah.
You get
17 minus 14
beautiful.
plus b
Yeah. Equals
2p plus
4.
plus 4.
I like it. Now I get a little cleanup, right? This side, nothing I can do, but this side,
So it'll be 8p.
good. So 7p and b is 8p.
Minus 14 equals b plus 4.
Now somebody had a good point. If I subtract 8, I'll get a -6. If I subtract 2, I'll get a 6. No, it's easier, but does it matter really? No. Because if I add 14, I get a positive 28. If I subtract 4, I get a -28. The signs will cancel themselves out. It'll be the same no matter which way you do it. But you got a good point. Don't bring negatives in if you don't have to. So here you get 6p minus 14 equals
Plus 4.
4.
Add 14.
Add 14.
6p equals 18. Divide by 6. You get
Divide by 6. P is 3. If you plugged it in, it would work.
27.
Yeah.
27.
27. Who's got a suggestion for a first step there? Besides erasing.
Subtract 1/4x.
Good. So one thing you could do, and this isn't really that evil of a problem to keep the fractions in.
Add the right side.
You could keep the fractions in, and they're relatively easy fractions because they have a very nice LCD.